an explanation of why the ball rebounds when it hits off an object. So what we have here is a ball traveling to the right, hits off an object, and the thing to remember is when the ball hits off the object hits the ball back. It always hits the ball back perpendicular to the wall also. And this force, or this thing that it hits it back with, is called an impulse. It's a striking force. Technically not a force per se. We'll see that it's a little bit different eventually. But what you need to remember is the ball hits the wall, so the wall hits the ball back, and it hits the ball back perpendicular to the wall itself. So as we can see with the diagram there, the wall is supposed to be green, the ball is travelling from left to right, and as a result there is an impulse force directed to the left. And what that impulse force does is it changes the velocity of the ball in that direction and that direction only. And that's really important for what we're doing next. So the impulse is perpendicular to the surface that the ball bounces off, and it changes the velocity of the ball in that direction only. Okay, and this is an application of it immediately. So if we have a ball, it's traveling at 10 meters per second, hits a plane at an angle. So think about a snooker ball not hitting the cushion straight on, but hitting it at an angle. If the striking angle is 30 degrees, calculate the speed of the rebound, given that the coefficient of restitution between the ball and the surface is a half. So what we're talking about is something like that. The ball starts on the left, traveling at 10 meters per second. There's an angle of 30 degrees between the velocity of the ball and the plane that is striking, which is the green thing, and then the ball rebounds off. So because the ball is hitting a horizontal surface, there'll be an impulse that's vertical. Remember, the impulse is always perpendicular to the wall when the ball strikes it. And the consequence of that is that it changes the velocity of the ball in that direction only. So the ball's velocity vertically here will change. Remember, it's just in the same direction as the impulse. For this question, the impulse will be vertical, so the change in velocity will be vertical as well. And that's evident from the diagram in that the ball is travelling down to the right initially, strikes off the cushion or the plane, and then travels up to the right. So it continues to go right, but instead of going down towards the plane, after it hits off it, it goes up towards the plane. And that's because the impulse force is vertically up, perpendicular to the plane. Okay, so there we go. Perpendicularly up, vertical to the plane. And what that does then is it causes the vertical component of the velocity to change. Now, on the right-hand side there are two sentences that are extremely important. The first one, the component of the velocity perpendicular to the wall changes, and we use E as minus V over U in the vertical direction, in this case, in the same direction as the impulse. And then the component of the velocity parallel to the surface stays the same. And you'll see what I mean by those in a minute. So what we need to do is get the velocity components before the ball hits the plane. And those are denoted by the red arrows on the left-hand side. Okay. What we'll also need to do is get the components of the velocity after the collision. And the things to remember here, again, are as follows. The two sentences on the right-hand side, the component of the velocity perpendicular to the wall or the plane, those are the vertical ones, change. So we can see that the two that are in the vertical direction, on the left we have one going down that's quite large, on the right we have one that's going up that is much smaller. In fact, they should be half the size because the coefficient of restitution is equal to a half. And the second sentence, the components parallel to the surface stay the same, so the horizontal red dotted line on the left-hand side should be the same as the horizontal red dotted line on the right-hand side. And that's because there's no force acting on the object in that direction, so the ball will keep travelling at constant velocity horizontally. That's Newton's first law. Okay, so let's get to it then. What we want to do is set up the triangle with the first velocity vector, and then using SOHCAHTOA, get the opposite, which is the vertical component, get the adjacent, which is the horizontal component, and we get 5 for that and 8.66 for that. Okay, we have our two components, and now we apply our rules. So the first rule was the component parallel to the surface stays the same. So what that means is that will be 8.66 as well. And then the second thing that we saw was the velocity perpendicular to the wall changes according to E is equal to minus V over U. So when you put in a half for E, you put in U as 5, V will work out as 2.5. Now the sign there should be a minus, but that's taken into consideration by the arrow on the leftmost of the diagram being down and the arrow on the rightmost of the diagram being up. So that's factored in. Now, all we need to do now is calculate the size of the velocity after the collision, or the speed after the collision. So we're looking for V. And basically we're looking at the right-hand triangle. We're looking for the size of the hypotenuse. We have an opposite and an adjacent of 2.5 and 8.66 respectively. So you can just use Pythagoras to work that out. You can calculate that yourself. The speed squared is equal to 8.66 squared plus 2.5 squared. So calculate the speed. The speed will be equal to the square root of 8.66 squared plus 2.5 squared. Right, example 2. So a ball is travelling at a speed of 14.14 meters per second, hits a plane at an angle. If the striking angle is 45 degrees, calculate the speed of the rebound if E is equal to 1.5. Now, I've done much of this question already. I've drawn the ball going diagonally down with the 14.14 being its speed before the collision. The angle is 45 degrees. Here we go. And using SOHCAHTOA, I can calculate the two components. They'll work out as 10. So 10 downwards and 10 to the right. Applying our rules then for the rebound velocity, the component of the velocity parallel to the plane stays the same, which is why we've got a 10 there. And then the component perpendicular to the plane, we need to use E is equal to minus V over U to calculate that. Basically, it's going to be a fifth of the 10, and as a result we get 2 upwards. And then to get the speed of rebound, we use Pythagoras to calculate the V value, and V will be equal to the square root of 10 squared plus 2 squared. Now gents, it's time for you to do some questions.